there is a theorem which is very important. Suppose f is Riemann integral on closed interval AB and fx is given to be bounded between small m and capital M for all x belonging to closed interval AB. And second thing, if phi is continuous on this closed interval small m and capital M and hx is equal to phi of fx on this closed interval AB, then I have to prove that h is Riemann integral on closed interval AB. Now here, two things are given to us. One is f is Riemann integral and is bounded between the values small n and capital M, right? And secondly, it is given that phi is continuous on this closed interval small m and capital M, right? And hx is equal to phi of fx, which means hx itself is a function which is depending upon the values of fx, right, on this closed interval AB. Now because phi is continuous on this closed interval AB and because it is closed and bounded, then phi is also uniformly continuous on this closed interval AB. So I will start the proof with the definition for uniformly continuous, right, for the function phi. One thing is this, and the other thing is that hx is equal to phi of fx. Because phi is continuous, I can get one more thing, that hx is also continuous. Because hx is what? It is function. That is phi depending upon fx, right? So if phi is continuous, hx is also continuous. So I am going to use the definition of phi to be as uniformly continuous function. And secondly, I will be using the definition for hx to be a continuous function, right? And also taking the help for f, that is Riemann integral given to us, I will be defining a partition P on closed interval AB. Fine. And after having these things, I will be prove that h is Riemann integral. So it is a step-by-step proof, just applying the definition. So let's start. Let epsilon positive be given, and our first step is to define phi to be uniformly continuous. It is yes on closed interval small n capital M, and I am using the definition for the uniformly continuous function. Let's start. Okay, since phi is uniformly continuous on closed interval small n and capital M, so therefore there exists delta positive depending upon the value of epsilon only. Now here, instead of writing depending upon epsilon only, I am using this that such that this delta depends upon epsilon like this. So here it's a trick I am going to use over here, that delta is strictly less than epsilon. I am taking this, right? And let me mark this as double star. It is very important. And then when this happens, so I will be having mod of s minus t less than delta, which implies, yes, mod of phi of s minus phi of t is less than epsilon for all s and t belonging to this closed interval capital M and small m. Is it fine? Okay. Secondly, let's start with f, which is given to be as a Riemann integral. So for that, I will be defining a partition. So since f is Riemann integral, so therefore there exists a partition P, which is equal to x0, x1, x2, so on, xn of closed interval AB, such that, what is the result? Yes, UPF alpha minus LPF alpha is less than epsilon. Now can I choose my epsilon to be equal to delta square? See, delta is depending upon epsilon and delta is less than epsilon here in this case, right? But here I can choose my epsilon to be equal to delta square. Yes, I can choose any epsilon, because epsilon is a positive, right? A positive real number, right? Epsilon is a positive real number, strictly greater than 0. I can choose my epsilon to be anything. So here I will be choosing epsilon to be equal to delta square, and delta itself a positive real number. Okay, so here you have to note this thing. It is very important to note over here. So two things you have to note. One is this, another is delta is less than epsilon, right? Okay, now let's define our capital Mi, which is of course supremum of f of x over xi minus 1 xi, and small mi to be the infimum of fx over xi minus 1 xi. Fine. Now let me define mi star and small mi star for h function, right? Mi star and small mi star, it is the supremum of hx and infimum of fx. We have defining for the function h. Now let me divide the numbers 1, 2 up to n. Now these numbers are the suffices of this x0, 1, x0, x1, x2, x3, x4. Let me divide these numbers into two classes. Why it is necessary to divide these suffices into two classes? Because I am having three choices. The difference capital Mi minus small mi, this difference can be greater than delta. It can be equal to a delta. It can be less than delta. Three possibilities. So let me divide these suffices into two classes where my I, if belongs to A, if this difference capital Mi and small mi, this difference is strictly less than delta, and if I belongs to be the other class, then this difference is greater than equal to delta. That's why. So I will be working for both these classes. Please remember that hx itself is a function which is depending upon the values of fx. Therefore, I have to take this difference to be either less than or greater than equal to delta. I hope it's very clear to you, okay? The fourth step is, now since h is continuous on closed interval AB, and because it is continuous, so it will definitely attain its maximum and minimum on this segment xi minus 1 and xi. And for that, I have to choose two numbers from this closed interval on which it attained its maximum value and a minimum value. So thus there exist, let me say, S and T are already there. So let me take, Pi and Qi belonging to this closed interval xi minus 1 and xi, such that suppose h of Pi is my maximum mi star and h of Qi at this value I am having the minimum mi star. Fine? Okay. Now because I have to work on both the classes, first, since for I belongs to A, let me see what happens. Consider this f of Pi minus f of Qi. Now we know that it is a result that small mi is less than equal to f of Pi, obvious, and f of Qi is less than equal to capital M, obvious. So from here, can I say the difference of these two values of the functions is their mod, this less than equal to difference of these two, small mi and capital M. It is a result. So from here, I can write this mod f of Pi minus f of Qi to be less than equal to capital Mi minus small mi. And what is the condition for this if I belongs to A? Let me see. If I belongs to A, then this difference is less than delta. So I'm writing here this is less than delta. Fine? Okay. Now going back to the definition for the uniformly continuous, whenever s minus t mod is less than delta, then phi of s minus phi of t is less than epsilon. So here, whenever this f of Pi minus f of Qi is less than delta, then I have to take the phi of f of pi minus phi of f of qi to be less than epsilon. So let me write. This is from star. Now what is phi of f of pi? Yes, this is h of pi. Why? Because hx is equal to phi of fx. It is given to us. Similarly, this will be h of qi. This mode is less than epsilon. Now what is h of pi from here? It is mi star minus, and h of qi is small mi star. Okay, because it is already a positive value. So what we get? We get thus mi star minus small mi star is strictly less than epsilon for I belongs to A. Why I need mi star minus small mi star? Because remember we have to prove that H to be Riemann integral. For that I am going to calculate UP H alpha minus LP H alpha. Next. For I belongs to B, let's see what happened. Okay. For I belongs to B, let me define capital M to be equal to supremum of hx mod, like in the previous theorem we have done on closed interval AB. Okay. So mi star minus small mi star is less than equal to, can I write 2m? Yes, because m is what? It is the supremum of mod of hx. And of course mi star minus small mi star, these are defining on the segments xi minus 1 and xi. But here a capital M is supremum on bigger interval, closed interval AB. Right? So of course this difference is less than equal to twice M. Now as I belongs to B, I know that this difference is greater than equal to delta. Right? I belongs to B, this difference is greater than equal to delta. From here I will be writing that delta is less than equal to the difference. Okay. Okay. Take the summation delta alpha on both the sides with this. So it is delta summation alpha I, and I must belong to B because I am going to consider the another class. This is less than equal to summation I belongs to B capital Mi minus small mi delta alpha I. Fine. Now consider this. I am considering this here again. So this is less than equal to summation I belongs to B capital Mi minus small mi delta alpha I. Okay. So this is equal to, this is what? Capital Mi delta alpha. This is, and the summation. This is UPF alpha. And because I am considering for the class B, so equality sign is not there. There should be less than equal to. So this is minus LPF alpha, right? Which is less than, yes, this is less than, using 1. This is less than delta square from the very start. Okay. So I am writing using 1. Because this is less than epsilon, and epsilon I have taken to be delta square, where I have written note. Okay, do you remember? Okay, let me show you. Here, from here. Now you remember? So this difference is less than delta square. So this is less than delta square. Fine? Okay. Which implies there is 1 delta. Can I cancel 1 delta from here? So this is summation I belongs to B delta alpha I less than delta. Delta cancelled out. Okay. And this delta is, yes, at the very start, delta depending upon the epsilon such that this delta is strictly less than epsilon. Fine? Okay. So what I get? I get that summation I belongs to B delta alpha I is less than epsilon. marking this as 4. So I will require this, the result for the second result, using 2, using this 3 and using this 4. Now I will calculate UPH alpha minus LPH alpha. This is equal to summation I going from 1 to n mi star minus small mi star delta alpha I, splitting this into classes when I belongs to A and when I belongs to B. So this is less than epsilon and summation is on this delta alpha I plus when I belongs to B, this difference is, remember, 2m, right, from 3. So 2m taking outside and summation is on delta alpha I. Okay, next. Now, this is what? This is epsilon, this is alpha B minus alpha A. Fine. Plus, this is 2m. Okay. Now, this summation delta alpha I, this is strictly less than epsilon from 4. So, I will write here sign strictly less than epsilon. Is it fine? Okay. Now, this is equal to, taking epsilon common, this is alpha B minus alpha A plus 2m, epsilon outside, and taking all together as to be epsilon dash. So hence, this is just your number. So UPH alpha minus LPH alpha is less than epsilon dash, but epsilon dash was arbitrary. Hence, H is Riemann integral on closed interval AB. We get the result that UPH alpha minus LPH alpha is less than epsilon dash, which is arbitrary. So H is Riemann integral. Easy. Alright, thank you for watching this video. Just go through all the steps. It's very easy. Just you have to define the definitions, using the results, splitting up to the classes, write step-by-step proof I have done. So it's easier for you to remember. Thank you so much. God bless you.